All right, for notes 5.5, we're going to be solving trigonometric equations. So we are going to solve for x here, figure out where our values, our trig functions, what their values are in the unit circle, okay? So it's super, super important that you know your unit circle for this section. I'm going to be walking you through some of those tricks at the beginning, but then we're just going to expect you to know like where cosine is square root of 3 over 2, or where sine is, square root of 2 over 2, whatever it is. So make sure that you go back and start studying that unit circle, please. Now, to solve these, there's some general guidelines that we're going to talk about, and then we'll kind of just jump right into it. When we're solving an equation and it has a single trig function, just one, so either all of them are sine, all of them are cosine, and so on, we just have to isolate the function on one side of the equation and then solve for the variable. Always go back and check for a greatest common factor. Now, sometimes it's going to look like a quadratic, so it's going to have cosine squared of x or sine squared of x. And we're going to factor out greatest common factor again. If you can, factor the two binomials, or you might need to solve by taking the square root of both sides. And lastly, when you're trying to solve and there are two trig functions, you're going to need to use that golden ticket to rename one of those functions using those identities in the golden ticket, because we really can only work with one trig function at a time. So you're going to have to rewrite some of these, okay? And generally, if the instructions tell you to solve for all solutions, this just means that we want you to add 2 pi n to the end of your answer. Okay, so if the instructions again say all solutions, that means you have to go back and add 2 pi n, because the 2 pi n represents the number of rotations around the circle. So even though we found the one answer, it'll apply. It doesn't matter how many times around we go in the unit circle. So anytime it just says all solutions, please make sure you include that, okay? Here we go. So let's go ahead and jump into some examples here. And here is the first one where it says solve for all solutions. That's my key word that I want to add 2 pi n to the very end. And thankfully, example 1 here only has sine. So I need to get all the signs to the same side of the equation. I'm going to start off by subtracting 5 sine of x. That's going to cancel out here. It's going to give me negative 2 sine of x minus 2 equals that negative 1. Then I'll go ahead and add the 2 over, which gives me negative 2 sine of x equals positive 1. And I'm going to divide by negative 2. So sine of x equals negative 1/2. So this is not your final answer yet. This essentially gets me to my answer. You need to think about where in the unit circle is sine equal to negative 1/2. Okay? Your final answer is going to be written as x equals. And think about, well, sine is the y value. So if I were to think about my unit circle, I know I'm below the x-axis. Okay? And the 1/2, it's going to be a 30-degree reference angle. So it's going to be like here and here. So what are those values? Where in the unit circle, radians, we want radian answers, is this going to be true? So it's going to happen at 7 pi over 6, so a little bit past the pi. And then remember, because we're doing all solutions, I have to add plus 2 pi n. But then it happens somewhere else too. So I'm going to add this bracket showing that I'm including 2 answers. And the second place it happens is at 11 pi over 6. And then don't forget, plus 2 pi n shows that every single time I come around and go to that point, it'll be true. Okay? So kind of working backwards, just think about where in the unit circle sine equals negative 1/2. And then if there's more than one place, then you would include both of those answers. Okay, going on to the next one. So still the instructions are saying solve for all solutions. And this time I'm dealing with tangent. So again, get the trig function by itself. So I'm going to move the 1 over. That leaves me with square root of 3 tangent of x equals 1. Then I'm going to divide by the square root of 3 tangent of x equals 1 over root 3. And then we have to rationalize the denominator or multiply both the denominator and numerator by square root of 3 over 3 because we don't like radicals in the denominator. So square root of 3 in the numerator and then 3 in the denominator. So again, this is the point where you ask where in the unit circle is tangent square root of 3 over 3. Okay? Now, and it's a positive square root of 3 over 3. That's important because that's going to depend, it's going to make a difference for our quadrants. Tangent and cotangent are going to be more of the complicated ones because you can't just say or use any of the tricks like where's the x value, where's the y value. Tangent requires a little bit more work. It requires you to know that, first of all, tangent is the same as sine over cosine, which means you have to figure out what combination of sine values and cosine values are going to divide out to give me square root of 3 over 3. Okay? In this case, the answer comes out to be square root of 3 over 2, 1/2. So it's going to again be a 30-degree reference angle. And when I divide, this is my cosine, this is my sine, I'm going to get 1/2 over square root of 3 over 2. You divide fractions by skip, flip, multiply, or however you learn that, and you multiply straight across. These cancel out, and then I'm left with 1 over square root of 3. But then, again, we multiply to get that, square root of 3 over 3. So you don't have to do all that if you already knew that this was the answer. So the 30-degree reference angle, I'm just showing you why that's the right answer. Because if I were to follow sine divided by cosine, that's how I get that same point that I was looking for. Okay? And now remember where tangent is going to be positive. And that's going to be in our first quadrant. So the first quadrant, 30-degree reference angle, is pi over 6. And because it's still asking me for all solutions, I have 2 pi n. And then tangent is also positive in the third quadrant. So I'm also going to include 7 pi over 6 plus 2 pi n. Okay, because in the third quadrant, these will be negative, and negative divided by negative is going to give me that positive. All right, so let's get into actually solving these equations on the interval 0 to 2 pi. So this just means that the answers need to be within the unit circle, okay? No longer need to add the 2 pi n. Need to be within unit circle. Okay. So we have a quadratic actually here, and this is a factorable quadratic. Now, in order to see this for this very first problem, we are going to go ahead and replace the cosine x with just x, okay? That way it looks a little bit more familiar. So if I were to replace every cosine x I see with just x, this problem would turn into a 2x squared plus x minus 1 equals 0. So we are really hoping that you guys know how to factor something like this at this point, but I will review just really quick. We are looking for two numbers that multiply to negative 2x squared and add up to my middle term of 1x. Often we get asked how we get that negative 2x squared. You always multiply your a and your c term to get this, okay? So numbers that multiply to a negative 2x squared is going to be 2x and x. One of them is going to have to be negative. And to determine which one's going to be negative, we see that the sum has to be a positive, which means the x is going to be negative, okay? Then we use what we call factor by grouping. And what we do is we split up this middle term into the two terms that we have found. So I'm turning this into 2x minus 1x, and then just bring everything else down. Bring down the minus 1, bring down the 2x squared. What we do from here is we're going to group the first two and the last two, and then factor out the greatest common factor from each. So here I have a 2x in common that can come out, leaving me with x plus 1 inside the parentheses. In the second parentheses, I have a negative 1, and that leaves me with x plus 1 here. Whatever you took out becomes a factor, 2x minus 1. Whatever we have in common becomes the second factor, so x plus 1. And then to solve for x, we would just set each of these equal to 0. So 2x minus 1 equals 0, x plus 1 equals 0. So when I solve for x, I get x equals 1/2 and x equals negative 1. Now remember, we at the very beginning replaced cosine of x with x. So this x is really cosine of x because we replaced it. So you should be asking yourself, where in the unit circle is cosine of x equal to 1/2 and cosine of x equal to negative 1? That's what this is. This is cosine of x. Those are the cosine of x values. So think about your unit circle, and then once you have those values, we're going to list them, okay? So where in the unit circle is your x value a positive 1/2? We're going to have 1 in the first quadrant, so that's pi over 3. And then 1 in the fourth quadrant, so at 5 pi over 3. So that takes care of the cosine of x. That's these two values for 1/2. And then where does cosine equal negative 1? So that's over at pi. Okay, so these three answers, these 3 points would satisfy this equation. This is where cosine of x is 1/2 and negative 1. In this case, there's 3 solutions. All right, let's go on to the next one here. So we have tangent of x, sine squared of x equals 3 tangent of x. And what I'm going to do here is I'm going to get everything to one side. We want to set this equal to 0. So I'm going to subtract tangent of x from both sides. Now be careful when we subtract the 3 tangent of x from the left. We have to put it somewhere. Don't combine these. These are not the tangent of x and sine squared of x at the beginning. They're not being added or subtracted. So I can't just subtract the 3 tangent of x from the tangent of x you see on the left. So be careful there. This really becomes tangent of x, and these are being multiplied, times sine squared of x minus 3 tangent of x. So really what I have here is I have 2 terms because there's a subtraction, and I actually see that they have a greatest common factor. They both have tangent of x that I can take out as the greatest common factor. So when I take that out, the first term is just left with sine squared of x. The second term is left with minus 3. And each of these are set equal to 0. So at this point, even though this original equation had 2 different trig functions, we are able to split them and create 2 different factors. So then I can take the tangent of x, set it equal to 0, and then I can take sine squared of x minus 3 and set it equal to 0. Okay, so just take these separately. There's no need to use any of my trig identities from my golden ticket, because these 2 factors separately can be solved. I can use them because they're just 2 separate factors being multiplied together, okay? So we're going to ask ourselves, where in the unit circle is tangent equal to 0? So think about, this is where my sine is going to be divided by my cosine. So what value would have to go in the numerator for this to simplify to 0? So 0 divided by anything, right? Any x value is going to be 0 at the end. So in this case, we are looking at, I'm going to write my answer off to the side, at 0 and pi, because if you think about it, it's going to be 0, 0, and then negative 1, 0. So when I take this one, I get 0 divided by 0, which is 0. And when I take this one, I have my sine over my cosine gives me 0. So tangent is 0 at 0 and pi. You remember, we don't need to add the 2 pi n because it's only asking us for the solution within one rotation of the unit circle. When I go on to my sine squared plus 3, I have to first add the 3 over to the other side. So I get sine squared of x equals 3. Then I have a squared term, so I know I can take the square root. That gives me sine of x equals plus or minus square root of 3. Now, where in the unit circle would I have a y value that's greater than 1? Okay, that's not possible. There is, if you think about the unit circle, it's called the unit circle because it's 1 unit in radius. So it is not possible to have a number greater than 1 within our unit circle. So that means that we only have these two answers. So this sine part was not helpful at all. I was only able to use the answers from the tangent, but you always have to go in and check. So it's possible not to have an answer if it's greater than 1 within the unit circle. Okay? All right, next example here, we have 4 cosine squared of x minus 3. And this one is already set equal to 0. But think about your unit circle. So you want to manipulate the equation in a way that's going to help you figure out the values within the unit circle. So we know the unit circle includes the value 1/2, square root of 3 over 2, square root of 2 over 2, and then a variation of those around. So in this case, because I have cosine squared of x, I actually don't want this just set equal to 0 because I see this 3. And if I were to add this 3 over, and because the value of cosine is being squared, I know eventually I can get this to be a square root of 3, which would really help me out, okay? So I'm going to do that instead. Still isolate your trig term. So I have this so far, and I get rid of that squared by taking the square root. So cosine of x, and this can technically split up into square root of 3 over square root of 4. The square root of 3 we're just going to leave alone, but square root of 4 becomes 2, and then this is all plus or minus. Okay, always include the plus or minus when you are taking the square root of a number. And again, you are asking yourself where in the unit circle cosine of x is positive square root of 3 over 2 and negative square root of 3 over 2. So cosine is going to be either positive or negative in all 4 quadrants. So we need to include all 4. If you didn't include this plus or minus, you would be missing 2 answers here. So super, super important that you remember to add that plus or minus anytime you take the square root of an answer, okay? So we have 1 in the first quadrant at pi over 6. We have 1 in the second quadrant at 5 pi over 6. We have 1 in the third quadrant at 7 pi over 6. And in the fourth quadrant at 11 pi over 6. And that would be my answer because, again, I was looking for all the positive and negative x values that would give me square root of 3 over 2 in my unit circle. Problem number 4 here. We have 2 cosine squared x plus 3 sine of x. So I'm going to want to change one of these. Looking at the cosine squared of x, I'm going to change this to be in terms of sine. And if you look at your golden ticket under your Pythagorean identities, you'll see that there's something that says sine squared of theta plus cosine squared of theta equals 1. So if I want to solve for cosine squared of theta, I would subtract the sine squared of theta over, which means cosine squared of theta actually equals 1 minus sine squared of theta, okay? Or in this case, x. So I'm going to take this and I'm going to replace it with 1 minus sine squared of x, and then everything else can stay the same. So that's how you use those trig identities to help you rewrite the equation so that you only have one trig function in the equation. So from here, I'm going to distribute this 2 multiplied through 2 minus 2 sine squared of x plus 3 sine of x equals 0. And for this to look more like a quadratic, I'm going to just rearrange it. I'm going to put my square term first. So 2 sine squared of x, and then my just a regular sine term. And then my 2, my constant, is going to move to the end. So all I did was just rearrange. Okay. Now, from this step, you need to factor this out. So again, you're looking for two numbers that multiplied at -4 add up to a +3. Hopefully you're able to do that on your own. And when we split up this middle term, this is going to become -2 sine squared of x plus 4 sine x minus 1 sine x plus 2. Then we factor by grouping the first two terms, the last two terms. Okay, and I can take out from this first one a -2 sine of x, which leaves me with just sine, and then minus 2. In the second one, I can actually take out a -1 sine of x minus 2. Whatever you took out becomes one factor, so that's -2 sine of x minus 1, and then whatever they have in common is your second factor. If you're still having trouble factoring, please reach out, okay? And then you're going to set each of your factors equal to 0. So -2 sine of x minus 1 equals 0. I add the 1 over, and then I divide by 2, or the -2. So I get -1/2 for that one. And then for this one, the sine of x minus 2 equals 0. When I solve for that, where is sine of x greater than 1, remember, or equal to 2? Where is that going to happen? It's not possible. So don't include that. There's nowhere in the unit circle that sine of x equals 2. So then really we can only use this. Where in the unit circle is my y value? -1/2. And hopefully you know your unit circle and you can tell us 7 pi over 6 and 11 pi over 6. And that would be my answer. Next problem, number 5. Here we have cosine of 2x plus 3 sine x minus 2. So looking at my golden ticket, I want to simplify this and either turn it into cosine or sine. Now this right here is called the double angle, and it is found in your golden ticket. And the double angle turns into cosine squared of x minus sine squared of x. Okay, and then I'm just going to bring down the rest of my equation that was originally there. Now looking at this part, I need to turn everything to sines. So cosine squared of x, again, rearranging the sine squared plus cosine squared of theta equals 1 can be rewritten as 1 minus sine squared of x, and then bring everything else down. Okay, so then again, this turns into a factoring problem. Well, we need to simplify a little bit first. So here we have 2 sine squared of x's, negative sine squared of x minus another sine squared of x can actually combine. If you have -1 minus 1, that technically gives you a -2 sine squared of x. And then we still have the 1 here, plus 3 sine of x minus 2 equals 0. Now then I can combine like terms and turn this into a quadratic. So I'm going to put my square term first, -2 sine squared of x plus 3 sine x, and then 1 minus 2 gives me just -1 equals 0, okay? So again, going back to your factoring, what two numbers multiply to 3 but add up to 3? and that's going to be me splitting out the middle term to 2 sine x plus sine x, and then the front is going to stay the same, and then the minus 1 is still here. We're going to factor by grouping. Group the first two terms and the last two terms. In the first one, we're going to factor out the -2 and a sine, which means I'm only left with 1 sine of x on the inside and then a -1. This second term, I can just take out a 1. There's not really much going on there. So my two factors are -2 sine of x plus 1, whatever we took out, right? And then the one that match, sine x minus 1. So I'm going to set each of these factors equal to 0. So I take sine of x minus 1, set it equal to 0. So I need to figure out where sine equals 1. So where in the unit circle does this happen? Same thing with -2 sine of x plus 1, set it equal to 0. Subtract the 1 and then divide by 2, you get a positive 1/2. And then again, where does this happen? So super important that you guys know your unit circle. We know that sine is going to be 1 at pi over 2 only. And then sine is going to be a positive 1/2 in the first and second quadrant. So that's at pi over 6 and then 5 pi over 6. And that's your answer. Okay, almost there. 2 more examples here. Here again, we have sine squared of x and then cosine of x. If I want to turn everything to a cosine, I know that sine squared, again, using that same idea that we did a few problems back, this can be rewritten as 1 minus cosine squared of x, right? So here's where I'm using the sine squared plus cosine squared equals 1, just rearranging it to solve for sine squared in this case, and then I'm bringing everything down. Then I'm going to go ahead and distribute the 2 from the outside into my parentheses. 2 minus 2 cosine squared x minus 3 cosine x. And then I'm going to rearrange it so that it's a more clear quadratic. I have my squared term, then minus 3 cosine x. That's a positive 2 and factor. So 2 numbers that multiplied at -4 but add up to a positive 3. So we're going to split up this middle term. Hopefully you're doing this. That's -4 cosine of x and positive 1 cosine of x is how that middle term splits. And I'm going to bring down everything else. And then factor by grouping the first 2, the last 2. Take out a -2 cosine of x, which leaves you with just 1 cosine here, and then a positive 2 here. The second factor, we can only take out a 1, leaving me with cosine of x plus 2 on the inside. So my factors are -2 cosine of x plus 1, and then what matches is cosine of x plus 2. So again, set each factor equal to 0 and figure out where does cosine of x equal, this comes out to be a positive 1/2, and where does cosine of x comes out to be a -2. Again, the unit circle doesn't go past 1 or -1 in either direction, so that's not going to work out. Thinking about where your x value, so cosine is a positive 1/2. We have 1 in the first quadrant at pi over 3, and then 1 in the fourth quadrant at 5 pi over 3. And that's your answer. Okay. Last example for this set of notes. We have cosine, again, that's a double angle, which is going to be rewritten as cosine squared of x minus sine squared of x. And this comes from your golden ticket. Then again, that cosine squared can be rewritten in terms of sine by replacing it with 1 minus sine squared of x, and then minus sine squared of x again, because that's part of the equation already. This happens again where we have a negative sine squared of x minus another sine squared of x. So now we have 2, so 1 minus 2 of them. plus sine of x. And then I'm going to rearrange it so that it's in quadratic form. So my square term first, and then sine of x, and then my positive 1. So again, factoring out what two numbers multiplied are negative 2, but add up to a positive 1. So we're going to split up the sign into a positive 2 sine of x and a minus 1 sine of x, because that's how I get a negative product but a positive sum. And lastly, we're going to group the first two and the last two. Take out a negative 2 sine of x, which leaves you with 1 sine of x inside, minus 1. And then take out a negative 1 for the second one, and we get sine of x minus 1. Okay? So your two factors come out to this. Set them each equal to 0. So where does sine of x equals? This time it's a negative 1/2. And where is sine of x equal to positive 1? So again, we are a positive 1 for my y value at pi over 2. And then a negative y value this time in my third and fourth quadrant. So that's 7 pi over 6 and 11 pi over 6. And that is the end of our notes.